Hello, good afternoon, students.
Good afternoon, ma'am.
Very good. So, from your response, I understand that you are able to hear my voice. That's good. Yesterday, we have discussed about dual input unbalanced output differential amplifier. By the time others also join, let us not waste our time. Just let me recap this dual input unbalanced output differential amplifier. Like a dual input balanced output differential amplifier, the DC analysis, everything is same. We have seen, right? And this is the dual input unbalanced output differential amplifier. Therefore, we are taking output at one end only. So it is also called as single-ended amplifier. And for this, we have carried out DC analysis. And DC analysis, have you derived these expressions, ma? IE, VCE, Q, which we have derived for dual input balanced output? Same expressions, same equivalent circuit. Have you derived again for practice sake? For the sake of practice, you please derive again, right? Then I also have mentioned about AC analysis, that is the equivalent circuit, how we draw, and after that how we carry out AC analysis, uh, KVL and KVL for loop 1 and loop 2, right? So after that DC analysis, after that AC analysis, KVL for loop 1 and loop 2, and similarly IE1 and IE2, right? And only difference from dual input balanced output differential amplifier to dual input unbalanced output differential amplifier, that is from double ended to the single ended, only difference is what? Output is taken at only one terminal, that is at VC2. So therefore, only that variation we are doing, remaining analysis is same. Yesterday I have spent sufficient time on that. Okay. So V0 is equal to VC2, which is equal to minus RC IC2, and IC is IE. Therefore, IE2 expression we have substituted from equation 9b, and direct 9b you have written here in place of minus RC into, in place of IEC2 you have written IE2, and you have taken this negative sign into the brackets, inside the brackets, and we have rearranged this expression, and with some assumptions like R, capital RE plus small re is equal to RA, because capital RE is far far greater than small RE. Therefore, finally we have derived that V0 can be expressed as RC by 2 RE into V in 1 minus V in 2. The difference between these two input voltages, V in 1 minus V in 2, is also indicated as VID, therefore VID. We are indicating with VID. So differential gain AD is equal to V0 by VID. So V0 by VID is the ratio of RC by 2RE. So that is what we got here. So the differential gain of dual input unbalanced output differential amplifier is RC by 2RE. And what is the differential gain of dual input balanced output differential amplifier? It is RC by RE. So from this expression, we understand that dual input balanced output differential amplifier gain is RC by 2RE, and dual input unbalanced differential amplifier differential gain is RC by 2RE. That means in words we say that the differential gain of dual input unbalanced output differential amplifier is half of the dual input balanced output differential amplifier, right? I repeat, the differential gain of the dual input unbalanced output differential amplifier is half of the differential gain of dual input balanced output differential amplifier. That's all, right? So if it is a double ended output, we get RC by RA. If it is a single ended output, we get RC by 2RA. That means half of it. That's all. Okay, yesterday we have seen that, and after that here itself I have mentioned what is R, I mean differential input resistance R in 1 and R in 2. That means dual input, unbalanced output. No, so both R in 1 or R in 2 you can calculate. That also I have expressed yesterday, and it is equal to 2 times beta AC into RA, beta AC into RA. Then what is the output resistance of dual input unbalanced output differential amplifier? What is the output resistance of?
Output
Is equal to
RC.
RC.
Not is equal to RC.
Very good. Excellent. Excellent. Okay. So all that we have seen yesterday, right? And now, today what we are going to do is the third configuration. What are the 4 configurations now? What are the 4 configurations of differential amplifiers?
Dual input balanced output differential amplifier.
Dual input balanced output.
Single input unbalanced output differential amplifier.
Right, right. Okay. So first one we have completed, and the second one also in yesterday's class we have completed. This is the third configuration, that is single input balanced output differential amplifier. Okay. So why this? Any one of you please respond. Why this is called as single input differential amplifier first?
Giving voltage.
Output and one collector only.
Why it is called
One
as
is
single
grounded.
input?
Another
Other
input is
input
grounded,
is
ma'am.
grounded.
Is grounded, ma'am. On transistor will give to the input.
Yes, yes. Okay. So other input, that 2 inputs, out of 2 inputs, this is one input, other input is grounded. That's why we call this as single input. What about output? It is balanced output. Same as in the previous case, dual input balanced output. Similar way we are taking here. If it is a balanced output, it means that it is we are taking output from 2 collectors, that is double-ended output. So all these, actually if you observe in internet, okay, everybody talks about dual input balanced output differential amplifier only. Remaining things they say just a single input means other input is shorted. Like that they will mention, you will not find any analysis, right? So, but because you are in a J2 system, you have 4 sets. So anyone, you will get only one question. That's why I am giving all the 4 configurations in a detailed manner. So I am giving you this circuit and its analysis also, right? Single input balanced output differential amplifier. So I am happy that you are able to understand what is a single input balanced output differential amplifier. So for this also, what about DC analysis for this amplifier? DC analysis.
Same as dual input.
Very good, very good. It is same as? Emma, once again you talk, I think volume I am not able to get. One of you.
Same as dual input, ma'am.
Who is that someone playing song?
Akhil, ma'am.
Akhil, yes. Akhil only playing songs? 4F9. Let me write this number. 4F9, sorry.
Ma'am, no, ma'am.
4F9 answered.
Yes, ma'am. I answered, ma'am.
He answered, ma'am, F9.
Okay, Akhil. Okay, right. Okay. So who is someone played? See, if someone doesn't by mistake, if you may keep your mic on, okay. Otherwise, you please mute your mics. So nowadays, I did not get the opportunity to correct you regarding your mic and cam, because you are tuned to my class. You are following very well. For that, I am happy. But suddenly, I heard someone's music. Okay, please be careful. Right. Now, this is the single input dual output differential amplifier. Then DC equivalent circuit. How do we, Akhil, how do we draw DC equivalent circuit? You are responding well.
Just remove the voltage.
Yes.
Voltmeter.
Yes. Very good. Okay. just you remove all AC voltages, and it is a single input circuit, therefore we remove V in 1 here, and this is the DC equivalent circuit. Okay, and now if we carry out DC analysis, what about DC analysis for this circuit? Any one of you? You are forgetting every day, right? What I said, DC analysis for all 4 configurations is complete my sentence. Is
Same.
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 Right, it is same.
Same.
Therefore, if you carry out DC analysis, what are the expressions you get? Same expressions, right? Yesterday also you have derived for dual input unbalanced output for any configuration, same expressions. Therefore, I am just moving forward. You write down these equations which you have written already. You have noted down already, right? So IE is equal to ICQ, which is equal to VGE minus VBE by 2RE, right? And then VCEQ is equal to, once again, under this, I think, have you taken this circuit diagram first of all? Single input and balanced output differential amplifier. Circuit diagram you please take, right? So I am not going to wait for you. You just either take, please draw it fast while I am explaining. You pay attention to my explanation, one side, and other side you please draw the circuit diagram. If at all, if you need some more time, I'll just wait for a few seconds, if at all, somewhere here and there if it is required, right? That's why by showing you your circuit, I'm giving more explanation so that parallelly, I hope parallelly you are drawing the circuit. Okay, so this is the DC equivalent circuit. You can draw it. So all of you draw this DC equivalent circuit. After drawing this DC equivalent circuit, we write KVL for the input loop, how we have done for dual input balanced output differential amplifier, first configuration. Similarly, we draw and we carry out DC analysis like this. Okay, we get these expressions. Okay, now AC analysis. While carrying out AC analysis, what we do, ma? Any one of you? 2 steps we take. While carrying out AC analysis, we take 2 steps. What are the 2 steps?
In transistor place,
Yes, very good, very good, very good. Though it is not in sequence, but it is exactly correct. In place of transistor, you replace that transistor with its T equivalent, small signal T equivalent model. That is step 1. Another step is shown here, underlined.
DC voltage are kept.
DC voltage is
DC
0.
voltages plus VCC
DC
and minus
voltage is
VE
0.
to 0. So for the actual amplifier circuit, that is now we are studying about single input, dual output, single input, balanced output differential amplifier we are talking. So for that, we are going to carry out DC and AC analysis. Just now I have shown you DC equivalent circuit. Now this is AC equivalent circuit, right? So this is by incorporating those 2 steps. Transistor is replaced with its equivalent T, and other one is VCC is grounded and VE is also grounded, VCC grounded, right? So this is the equivalent circuit. All of you will not find this circuit anywhere, I think, right? So you please draw this circuit, equivalent circuit. This is the DC, AC equivalent circuit. You please draw it. Transistor is replaced by its equivalent circuit, because this is very important. The same circuit you just observe, I'm going to rearrange. Okay, so this RE is there, right? What I'm going to do is this current IC1, the directions also you please observe properly, because this what I'm going to do is from here I'm going to, this is ground only, no? So this ground I am going to bring it here and connect here. That means between this ground and this point, between this ground and this point, what we have? IC and RC. So those I'll draw here. Similarly, what I'm going to do is the other side here also, between this point and the ground, this current source, I mean IC2 and RC are there. So this I'm going to connect here, right? So in that manner, and here what we do is this RE is like that, and you will be able to see the circuit, equivalent circuit. Okay, have you taken this circuit diagram?
Yes, ma'am.
Yes, good. So this is the circuit. Okay, this RE you can see, this middle RE, capital RE, this capital RE, and towards left and towards right small RE is there, and at that junction I told you R in, of course there we have R in and V in one, and from collector to ground I brought that terminal this side and I have connected here. So this side also, this from that terminal we have connected to the ground. So this is the equivalent circuit for the previous circuit. Once again I will show you the previous circuit. Okay, this is the previous circuit, right? This RE, and towards right one RE, small RE, towards left small RE, and at this junction, from junction to this R in one and V in one, and this is IC1 and RC, and this side IC2 and RC. So for that circuit, this is the exact equivalent circuit. Just we have pulled down, that's all grounds we have connected in the same place to make our analysis easier. Same circuit, so we have drawn once again in a convenient manner, that's all. You please note down this circuit, right? VC1 RC, after that here VCC should be there, that is connected to ground, and IC1. Current directions what are there in the previous circuit, same directions are given here, right? There RS1 we have, RS1 and input resistance of the transistor, all these putting together we have named it as R in, and here it is a single input double dual output. What is that? Single input balanced output. Okay, so a single input, now V in you can write or V in 1 you can write. So because only if there are two we can write V in 1 and V in 2. If it is only one we can write V in only, but for what is that standard notation sake I am writing sometimes V in 1, sometimes V in, both are same, right? So V in 1 I tried to continue with V in 1 only. So you please see this circuit I have drawn. You please note down this circuit. Okay. After noting down, what we do is actually there are some 3 nodes here. 3 major nodes are there. 3 or 4 like that. So what we do, why we carry out mesh analysis or nodal analysis? Mesh analysis or nodal analysis to solve for unknown currents and voltages. Okay. So if we consider in this manner 2 loops, loop 1 is within this loop, right? What I have shown here. This is loop 1, right? So within this loop, if you write KVL, algebraic sum of voltages in a closed loop equal to 0, within this loop if you write, you will get one expression, and again we start from here only, and like this I have extended this loop to this, that is loop 2, right? So the same thing I have indicated in black color, right? Just I will erase these once again just to show you the direction I have drawn again, right? So these red lines now I am removing. Right? Just for understanding sake, I have shown you this. Right? So loop 1 and loop 2 you have identified, right? So are you able to follow what is loop 1? This is loop 1. how I have indicated here, and this is loop 2. Now let us write KVL to loop 1 and after that write KVL to loop 2. If we have two equations and two unknowns, we can use our Kramer's rule and we can calculate the unknown expressions. We can derive expressions for IE1 and IE2. Shall I move a little bit forward?
Okay,
Yes,
ma'am.
ma'am.
Good student. Right. So single input balanced output differential amplifier. For that we are writing KVL for loop 1 and loop 2. I'll just show you V in 1 plus IB1 R in 1 plus IE1 RE plus IE into RE. Right. Here if you observe, I have written I capital E. Once again I am going to the previous slide. Right. You note down this equation first and then I will show you here, right? This is what? Minus V in 1, here from here I start. So minus V in 1 plus IB1 R in plus IE1 RE, and after that this component RE into, here if you observe what happens means the current that is flowing here, this IE1 will be divided into two branches. Therefore, what is that? IE1 and the current that is going other side, we are indicating it as IE2. Therefore, IE1 minus IE2 will be flowing through this branch. So that is IE1 minus IE2. That is the current distribution. So therefore, I have indicated with the letter I through capital RE. Therefore, just we have taken this notation, right? So that is equation 1. Equation 1, minus V in 1 plus IB1 R in 1 plus IE1 RE plus IE RE equal to 0. This is equation 1. Is this equation clear to you, ma?
Yes,
Is this
ma'am.
equation clear to you?
Yes, ma'am.
Yes? Okay, I repeat once again. This is minus V in 1, one component. This is second term, and this is third term, and this is fourth term. That's all. Algebraic sum of voltages in this closed loop equal to 0. That is minus V in 1 plus IB1 R in 1 plus IE1 RE plus IE into IE1 RE into IE1 minus IE2 or I capital E. So this is KVL for loop 1, right? Now when we take KVL for loop 2, what are the other terms we get? This term and this term plus this term and again this term equal to 0, right? So let me show you the second KVL also, right? V in 1 minus V in 1 plus IB1 into R in 1, IB1 into R in 1 plus IE1 RE. Previous case we have come down. Now in this case we are going towards right, that is IE2 RE in the circuit. Are you able to understand? Right. Plus IE2 RE equal to 0. So this is equation 2. Now you can observe as usual IB1 can be expressed in terms of IE1, and then what is that? You rearrange this and you take these constant terms to the other side, right hand side of the equal to, and you get expressions for you get equations in terms of IE1, IE2, equation 2 also in terms of IE1, IE2, and finally what happens means, see, IB1 you express IE1 is equal to IB1 is equal to IE1 by beta AC, IB2 is equal to IE2 by beta AC. So you express wherever you have IB1 in previous equations, you write these equations, and wherever you find I capital E, you write IE1, IE2, right? You substitute those, and we also know that R in 1 by beta AC is this term can be neglected, and therefore finally you can write, after doing all this for the previous, that is dual input balanced output differential amplifier, we have done all that. Okay, so similar way, right? You please do that and you will get expression in terms of IE1, IE2, V in 1 and IE1 IE2, VIN2. So like that you get expressions, equations 3 and 4, right? So all these intermediate steps I have done exactly for dual input balanced output differential amplifier, and therefore we have done it in a very detailed manner. So just rearranging these equations by substituting this value, and that's why I have stressed that much there, right? You just substitute these values and then you neglect these values and try to express these in this manner, right? So I think you can also write these KVL, these expressions, this resistance matrix, all that by inspection also. In circuit analysis, you have done all that. By inspection also, you can write this matrix, right? So again, if I move towards that, again, you will ask me to explain about all that by inspection, how we write, okay? If you remember that, okay, otherwise in this manner, you please do. So equations 3 and 4 are the expressions that we got for what is that, deriving required values of IE1 and IE2, right? So now one of you tell me, after getting equation 3 and 4, what are the next steps that we have to take? One of you tell me, we got two unknowns and two equations. Two unknowns and two equations are there. So what we have to do later?
Cramer's rule.
Very good, right? So we have to apply Cramer's rule. So from this, one of you tell me what is delta? Anyhow, I have written in the next slide, but still, I want to check your
Small RE plus capital RE
small RE plus capital RE. Very good.
minus RE
Minus RE, excellent.
RE
RE, very good, very good. Then that is delta. What is next matrix?
delta 1
Delta 1. Tell me delta 1.
V in 1 minus
V in
RE minus RE V into RE.
V in 2 is not there, no? Now only this is single input.
V in 1 only, ma'am.
Both the cases V in 1 only. Very good, right? So then one of you tell me delta 2.
RE plus capital
Very good.
Capital RE or
to
small
V
RE. A one V in one.
in 1 RE.
Very good. Right? So this is the matrix. Any slow learners? Just now your friends have mentioned all this, right? If there are any slow learners, for the sake of these slow learners only, I have written here once again. You please note down this, right? If at all, if you are not able to follow means if you listen, you will follow, but in between, if you deviate, you cannot follow, right? So such people, don't deviate. You please note down this. And from this, just now your friends have mentioned what is delta and what is what is delta and what is delta 1 and what is delta 2, right? So after getting this delta, this cross multiplication and determinant value we write here, and finally you expand that, and you after rearranging this, you will get this expression. RE into small re plus 2 into capital RE is delta, and similarly delta 1 you expand, just multiply, cross multiplication, and you will get like this, V in 1 into RE plus RE, and delta 2 you just cross multiply, V in 1 into RE plus RE minus V in 1 into RE. So those two terms will get cancelled and you will get V in 1 RE. So after getting delta 1, delta 2, what we have to do, ma? One of you? After knowing delta 1, delta 2, what is our next aim? Next step. What is the purpose of writing this delta 1, delta 2?
I6
2 point IE1 IE2 value.
Very good. IE1 and IE2. IE1 is equal to
Delta 1 by
Delta
delta.
delta 1 by delta. IE2 is equal to
Delta 2 by 2.
delta 2 by
Delta 2
delta.
by delta.
Yes. So that is what. Okay. So what you have mentioned in your own words, you just I'm just showing here. You please write down in your notebooks, right? IE1 is equal to delta 1 by delta, which is delta 1 just now we have simplified. Delta also we have simplified. And finally, after writing this delta 1 by delta, here you can do our as usual RE, small re plus capital RE is equal to RE. We replace because that is capital RE is far greater than small re. Therefore, we neglect it. I mean, we replace it with capital RE only. And here small re plus 2RE. 4C5 నోట్ చేయండి ఒకసారి. ఏమా రాఘవేంద్రరావు 4C5
Yes, ma'am.
mute
Okay,
your
okay,
mic.
sorry, ma'am.
From you only, no? Noise is coming. Right. Don't allow me to say such things because by now, beginning classes, okay. By now, all of you got tuned to your online classes. Actually, I must know your welfare also, but every day I am very busy, and I am trying to take you through Lika subject only. I hope all of you are good and happy and healthy, right? So IE1 is equal to here as usual our simplification, right? RE plus small re plus capital RE equal to RE, and small re plus capital RE is equal to 2RE. Then with that simplification, you will get only V in 1 by 2 RE. IE1 is equal to V in 1 by 2 RE. Similarly, you calculate IE2, you express IE2. IE2, here you have RE plus 2RE is equal to 2RE we replace. So 2RE means this RE and this RE gets cancelled. Then V in by 2RE. That means IE1 is equal to V in 1 by 2RE. IE2 is equal to V in 1 by 2RE. Right? So why we calculate this IE1, IE2? We want to know what is IC1, IC2. Why do we want to know IC1, IC2? We want to calculate what is output voltage. What is output voltage? That is measured at the collectors. So there, what is the current flowing? We should know. That's why we are doing all that. So now let us move a little forward. That is the output voltage V0 is equal to VC2 minus VC1, right? So what is VC2? VC2 is IC2 RC, and VC1 is from the previous circuit. If you observe, it will be minus IC1 RC. I'll show you what is VC1, right? I am going to the equivalent circuit. This is VC1, right? With respect to ground, if you measure, this is the same circuit, the previous circuit only we have redrawn, right? When we redraw like this, when you observe the same circuit here, right, you will get between the ground and this with respect to ground, if you measure voltage here, you will get minus, right? So therefore, we are writing minus of IC1 RC, right? This voltage, and here this side you will get plus only, right? That's why our V0 is equal to IC2 RC minus IC1 RC, because IC1 direction is in the other direction, so voltage drop across resistor will be in this direction. So with respect to ground, therefore minus IC1 we have written, right? I hope by seeing that circuit you got clarity here. So minus IC1 RC, and now finally what we get is RC into IC1 plus IC2. IC1 plus IC2. So IC1 is equal to IE1, IC2 is equal to IE2. Therefore, in place of this, what we write? IE1 and IE2 expressions. So V0 into RC, and IE1 and IE2 both are same. V in by 2 RE we got, just now we have derived. V in by 2 RE plus V in by 2 RE, right? So 2 RE common and 2 times V in 1 or V in 1. So finally what you get is V0 is equal to RC in V in 1 into RC by RE. V in 1 into RC by RE. For a single input balanced output differential amplifier, output V0 is equal to V in 1 into RC by RE. And after that what we do? We define after calculating V0. How we calculate V0? By knowing IC. How we know IC? By knowing IE1. How do we calculate IE1, IE2? By writing KVL, KCL. That is the path we have taken. So now after calculating V0, after expressing what is V0, we calculate what is the next step? Tell me, ma. Every time what we are doing, first we are calculating output V0. After that?
Internal resistance.
After that? Somebody is responding. I'm not able to hear.
Input resistance.
Before
Differential
that?
input resistance.
Differential input resistance and also?
Differential input output. Internal output resistance.
Voltage gain.
Yes. Someone said?
Voltage gain.
Yes. Differential voltage gain. So after calculating V0, what we are doing? Differential gain AD or differential voltage gain AD is equal to V0 by Vi. For every amplifier, what are the 4 parameters that we have to calculate? One of you respond. For any amplifier.
Current gain is
Input
undefined.
resistance, output resistance.
Yes. Voltage gain, current gain, input resistance, output resistance. So for our differential amplifier, we have mentioned that current gain is undefined. This is mainly used as a voltage amplifier. So I told you, I have kept it to the last slide, why this current gain is undefined. Okay. Now, only 3 parameters we are calculating. What are the 3 parameters? Differential voltage gain, input resistance and output resistance. So just to calculate differential voltage gain is equal to output voltage by input voltage. So to get this output voltage expression only, we are doing that much analysis, AC analysis, right? After calculating what is V0 just now we got it is V in 1 into RC by RE, and gain is equal to output voltage by input voltage. So this V in 1 and this V in 1 gets cancelled. Finally, the differential gain of single input balanced output differential amplifier is RC by RE. Capital RC by RE. That means collector resistance by emitter resistance, small emitter resistance. Okay. So now let us recall once. This is the third configuration we are studying. So what is the first one we have studied? First one what we have studied? First configuration.
Dual input balanced output.
Very good. Dual input balanced output differential amplifier. For that is a balanced output differential amplifier. How much gain we got? AD expression. AD is equal to
RC by 2 RE.
You see differential amplifier, there are 4 configurations. First one is dual input balanced output. Second one is
Unbalanced.
dual input unbalanced output. Now the third one we are doing, this is single input balanced output.
Input balanced output.
Right? Now For the first one, I'm asking for dual input balanced output differential amplifier, what is the differential gain expression?
RC by RE.
Very good. RC by RA. Now for this single input balanced output also, differential
Same.
gain is
RC by R.
RC by RE only. That means if it is a balanced output differential amplifier, the gain is same, right? But for single input, for dual input unbalanced output differential amplifier, what is the gain?
RC by 2
For
RE.
unbalanced one,
Sorry.
RC by 2 RE.
RC by 2 RA, right? So now you got a clear idea. And of course, the input resistance, because it is a, now we are studying third configuration, that is single input, balanced output. So single input means input resistance that is measured at that single input only. That's why we are not writing it as R in 1 or R in 2. We are writing only R in, single input only. Therefore, R in, when the other terminal is grounded. Already other terminal is grounded. Therefore, according to the definition, this Rn is equal to same value we get, right? So what is same value? Rn is equal to, what is the definition actually? Rn is equal to V in 1 by Ib1. That means V in 1 by IE1, right? So what is V in 1 by IE1? IE1 expression you got. So you substitute here. All those terms will get cancelled. And finally you will get Rin is equal to 2 times beta AC RE. Right. Similarly, what is this? What is this?
Output resistance.
Output resistance. Good, good. Right. Output resistance. R01 is equal to R02 is equal to how much? RC. What is the definition? We have learned this definition already. What is the definition? For output resistance. Output resistance is the resistance measured at either terminal with respect to ground. Have you
Ground.
noted down that statement in your book?
Yes, ma'am.
You write down, writing one time is equal to reading 10 times, right? Therefore, you please write down. Okay, nowadays, I think for you, we have to change this proverb. Actually, olden days, our seniors, that means our parents age group people, they used to write and study. So that's why they used to say, my age group people, we used to read only, right? So they used to say us, why you are only reading? You please write. One time writing is equal to 10 times reading, right? They used to say. Now you are our next generation. Next generation means, next generation people. What you people are doing? You are neither writing nor reading. You are taking screenshots. So if you just take screenshot, that is not sufficient. You have to read, and if you write, it will be equal to 10 times reading. If you take only screenshots, that will be stored in your phone's memory only, but it will not be transferred into your memory, in your brain, right? Therefore, all of you please write. And is this single input balanced output differential amplifier clear to you or not? Is it clear or not?
Yes, ma'am. Clear, ma'am.
Yes? Okay, good. Right? Once again, I think repeatedly I am saying no, I think by now those are listening, for them it will be like boring only because so many times, several times I have repeated. Shall I repeat? Or shall I move forward? Shall I repeat or shall I move forward?
We don't know.
Okay. Right? So I think those who are listening, they are following. So okay, for my satisfaction sake, let me go once back and tell you, then only I will be more happy, right? This is what we are learning today. Single input balanced output differential amplifier. This is the circuit. Why we call it as single input differential balanced output, we know, right? only one input is there, right? Only one input is there. So here you can write it as V in 1, because there is a chance for two inputs, we are writing V in 1. Otherwise, you can neglect this one. You just simply say V in, that is also sufficient. And for this, we have to carry out DC analysis. And DC analysis is same for all 4 configurations. So the manner in which we have carried out DC analysis for dual input balanced output differential amplifier, same way you can connect this. You can carry out this and you write IE and VCEQ, and after that you carry out AC analysis, right? While carrying out AC analysis, you people also have mentioned 2 steps we have to take to draw the DC analysis, to draw AC equivalent circuit. Set DC voltages 0 and substitute small signal T equivalent circuit. And after that, this is the when we follow those 2 steps, this is the equivalent circuit. And for this circuit, just I have dragged this RC between ground, and I have just rearranged the same circuit in as this in this manner. So if you follow from there to here, then only writing KVL for loop 1 and KVL for loop 2, and after that we substitute these values and we apply Kramer's rule, and we write these expressions, these matrices R, I and V. After that, calculate determinant value, simplify some terms and ignore some terms, and finally you will get IE1, IE2, and after that V0 is equal to VC2 minus VC1, and VC1 is minus of IC1 RC. So I have shown you why it is minus of ICRC. See, voltage drop, VC1 is voltage drop across this resistor, right? To this resistor, actually IC1 direction is in this direction. Therefore, we want this. Therefore, we are writing minus IC1, right? So that's why minus IC1 RC, that is the voltage drop across this RC, and finally IC1, IC2 are replaced with IE1, IE2. IE1, IE2 expressions we already got. After getting V0 is equal to V in 1 into RC by RE, we have gone to what is that? Differential gain definition once again, that is AD. AD is equal to V0 by V in or V in 1. So when we write that, we get differential gain is equal to RC by RE. And the definition for differential input resistance we have. One of you please define what is the definition for differential input resistance. What is the definition for differential input resistance? Is the resistance measured? Differential input resistance is the resistance measured at either
terminals,
input
while
terminals.
other input terminal is grounded.
Very good, very good, very good, right? So other terminal grounded. So those expressions also we have done for previous cases. So same way, if you write, you will get 2 times beta acre, beta ACRE, and similarly output resistance R01 and R02. Here R in 1 and R in 2, no chance, because it is a single input balanced output. Therefore, R in only, and here because we are taking at 2 terminals, R01, R02, which is equal to RC, right? So this is what about single input balanced output differential amplifier. Okay. Then what is the last configuration we have?
Single input unbalanced output differential amplifier.
Yes. Now, how do we carry out single input unbalanced output differential amplifier? What will be the circuit diagram? What will be the circuit diagram?
Giving only single input and taking output at
Other terminal.
selector.
Right, right. Okay. And I think all of you can draw this single input unbalanced output differential amplifier. Okay. After this class, I think we are coming to the end of the class. Therefore, I think you can do this after this class at home, right? So can you draw this single input unbalanced output differential amplifier? Right? Can you draw or not? Right? Whether you draw or not, I am just showing you this is a single input unbalanced output differential amplifier, right? So single input unbalanced output. What is the difference between this case and previous case? Single input is as usual, and here we don't have, right? You just observe, I have short circuited this second source, right? And a single input, and earlier we have taken between two collectors, that was the balanced output. Now we are taking only at one collector, that is unbalanced output. Okay, so we have followed all the conditions, DC analysis, AC analysis, all these are same. All these are same, right? Only thing is, earlier we have taken, for balanced output, we have taken output from two transistors. Now, two transistors, collectors of two transistors. Now, V out is equal to VC2, right? V naught is equal to VC2. V out is equal to VC2. What is VC2? You tell me. VC2 is nothing but this drop. IC2 RC. IC2 RC. What is IC2? IE2. What is expression for IE2? In the previous one single input case you have derived. So therefore that expression you can.
Delta
Yes.
2 by delta.
Yes. Okay. So that IE2 expression you can substitute here, and you tell me, one of you, what is V naught? What is V naught? You tell me. V naught is equal to IE2 RC. IE2 expression already we have derived just now for the previous case. This case and previous case both are same. Earlier output only variation is there. Earlier we have taken output at two terminals. Now we are taking at one collector only, single ended output. So therefore IE1, IE2 expressions, all these are same. Therefore one of you can tell me what is V naught. What is V naught?
IE to us.
Very good. IC2 into RC, IE2 into RC. What is IE2? IE2 expression.
Delta 2 by
V in 1 by 2 R.
1 second. Emma, what is IE2? V in 1
Delta
by
2
2
by
RE. V in 1 by 2 RE you got. Right? So what is V naught expression finally?
V in 1 RC by 2 RE.
RC by 2 RE. Excellent. Very good. 1 minute ma download. Right. Yes, once again you repeat ma.
V in 1 RC by 2 RE.
Very good. V in 1 RC by 2 RA. And from that what we have to calculate when we get V naught?
Differential voltage gain.
Very good. Excellent. So what is the differential voltage gain? AD?
RC by 2 RE.
RC by 2 RE.
Very good. AD is equal to V naught by Vn. It is equal to RC by 2 RA. Right. So after that you tell me what is the differential input resistance?
2 beta AC RE.
Very good. 2 beta AC RA. Definition we know. Same values we substitute. Previous case what we have done? Same thing only. And what is R naught?
RC.
This is unbalanced output only. Therefore we say R naught only. Right? What is R naught?
RC.
RC. That's all. So Someone playing songs? 4D2, no. This one only. Akhil, from you only we are getting songs?
Ma'am, no, ma'am.
Only yours is getting highlighted and I'm hearing some songs.
Ma'am, I'm saying
Okay.
answers, ma'am.
You are giving answers, I know. Right, you are following well, you are giving answers. Okay. Then we'll see who is that person. Of course, it is being recorded. Your name will be highlighted in that record. In that record, I will observe later. Right? Okay. Now, this is the circuit we have. Right? This is the single input unbalanced output differential amplifier. Right? For this, I need not explain anything because just now in words, just by inspection, you people have expressed all these, right? V0 is equal to Vc2, which is equal to Ic2 Rc, right? Which is equal to IE2 Rc, right? And why, even after giving answers, why I'm showing this slide means for the sake of slow learners, right? So they will think, I don't know what madam is telling, they may feel. If you follow my words, you will understand exactly. And I am very happy that you people are following very well and giving response, right? So V0 is equal to Vc2 is equal to Ic2 Rc, which is equal to IE2 Rc. And after that, in place of IE2, we substitute what is IE2. That is nothing but V in 1 by 2 RA. V in 1 by 2 RA. We have derived it earlier. Just refer. So that we have substituted here. And after that, we have defined differential gain, which is equal to V0 by V in 1. And which is equal to V in 1 into RC by 2 RE. This V0 divided by this V in 1. So finally, you will get RC by 2 RE. So from this, what you understand? This is a single input unbalanced output differential amplifier. For a balanced output differential amplifier, differential gain is RC by 2 RE. If it is an unbalanced differential amplifier, differential gain is RC by 2 RE, half of that. Okay. For balanced, it is RC by RE. For unbalanced, it is RC by 2 RE. And beta ACRE, input resistance, output resistance, all these are same, right? So all these, for summary, I am just showing this summary to you. Just try to follow this, right? The configuration and each one of these configurations and their differential gains and their input and output resistances. Okay, so dual input balanced output differential amplifier. If it is a balanced output differential amplifier, gain is RC by RE. RC by RE. If it is a balanced output differential amplifier, gain is RC by RE. If it is unbalanced, that is single ended, then the gain will be half of it by 2. That's all. If it is unbalanced, the gain is by 2, half of it. So it will be very easy for you to remember all these. So these differential amplifiers, 4 configurations I am completing today. And in the next class, we are going to learn a few more concepts regarding these differential amplifiers, some 1 or 2 concepts. And after that, within 2 more classes, we may move forward to Unit 2. We have come to the 80% of our Unit 1 syllabus is over. So in this entire syllabus, we have dual input balanced output differential amplifier. If you learn that, you will get other 3 also. So steadily, if you write all these expressions, all these steps, what all I have mentioned, if you do for one single input, dual input balanced output differential amplifier, all others will be very, very easy for you. Otherwise, it will be very difficult, right? So you just do this and Are you able to follow this summary? Right, now we have reached this we have come to the end of this class. Now I stop here. If possible, tomorrow once again I want to say a few more words regarding this summary and about current gain, and after that we move forward to another concept. Okay, so let me see students available. Right. Okay, ma. So for today, I'm going to stop now, and in the next class, we shall see the summary. So what you have to do, you carry out this analysis. Don't keep empty in your notebook. Single input, unbalanced output, differential amplifier. All these steps, what we have done till now, those steps you repeat in your notebooks. When you come back, I'll verify your notebooks. Otherwise, one day I'll take it as a revision class, and that time I ask you to share in our chat box, right? You please keep your notebooks ready. So shall I stop here?
Yes, ma'am.
Okay, good. Okay, work hard, right? Study well, work hard, and don't waste your time. So future is yours. Wish you all the best. Okay, you all can leave this class now.
Okay, ma'am.
Okay.
Thank you. Bye.
Thank you,
Okay,
ma'am.
bye.